So dear students, now we are going to start this new chapter that is called gravitation. Gravitation. As you can see in the photograph, students, that in this chapter we are actually going to study about planets, about stars, regarding our solar system, space. So this is going to be a very interesting chapter, students. You are going to love it, students. So let us start this. So students, our story of this chapter will start with this great scientist, Isaac Newton, students. He is one of the greatest scientists, or perhaps the greatest scientist world has ever seen. The only other scientist which has perhaps matched him is Einstein. Einstein, you must have heard his name. He was also a great scientist. So Newton and Einstein, they are considered to be the most intelligent people that have ever lived on this earth, the greatest scientists that have ever lived on this earth, students. So students, the story goes back to 1665 when Isaac Newton was only 23 years old and he used to live in England, students. You understand? So once he was actually sitting down an apple tree. So it's a very famous story, students. You'll hear it at many places. And he noticed that apples fall down, apples fall down, apples fall down, he noticed that. So he wondered that why apples are falling down, why apples are falling down, why they are not going up, you understand. So he wondered that why apples fall only in downward direction, why they don't move up automatically, as they are coming down automatically without anybody actually pulling them down. Why don't these apples actually move up? He pondered on this question, students, for years. Then he came up with a very important theory of physics, and that theory is commonly known as universal law of gravitation, students. Now, according to this theory, or according to this law, what happens? Let me tell you. Suppose there are two objects, students. Say this object has mass m1 and this object has mass m2. Okay, students. And the distance between these two objects, say that is called d. So d is the distance between these two objects. Now, as per this theory of Isaac Newton, these two objects will attract each other. They will attract each other. So this object is going to attract this, and it is going to apply force on this object in this direction, students. You understand? And this object is also going to apply a force on this object in this direction, students. You understand? So both the objects are going to apply force on each other, and they are going to attract each other like this, students. And this force of attraction, is called gravitational force, students. Gravitational force. You understand? So if we have two objects of mass m1 and m2, and they are placed at some distance d from each other, they will attract each other, students. This object will attract this by applying such a force, and this object will attract this by applying such a force. And this force is called gravitational force, students. You understand? Now let me tell you some more important things regarding this force, students. So the first thing which I can write here is, the first thing which I could have written here is that this force of attraction is called gravitational force, students. Now the second point regarding this force on both the objects, is same, students, right? So the force acting on this object and the force acting on this object is same in value, students. If this is equal to 10 Newton, this will also be equal to 10 Newton. If this is equal to 100 Newton, this will also be equal to 100 Newton, students. You understand? The next point is these two forces are action-reaction pair. These two forces are action-reaction pair, actually. Forces act along the line joining the objects. Okay, students. So see, you can join these objects along this line, right? You can join these objects along this line. So both these forces are acting along this line, students. That is what is being said in this point. Now, students, the most important point. What is the value of this gravitational force? What is the value of this force which is acting on both these objects? So students, value of this force is given by this formula, G m1 m2 divided by d square. So students, let me tell you what are these terms here. You clearly understand what is m1 and m2. These are the masses of the objects. You clearly understand what is d here. That is the distance in the objects. Now there's a new term here, students, G. What is this G, students? So G is called universal gravitational constant. Universal gravitational constant, students. G is called universal gravitational constant, and its value is 6.673 into 10 to the power minus 11, students. That is its value. And students, this value of G was given by a scientist called Henry Cavendish. So students, what this scientist did, he gave the value of G. He told the world that the value of G is 6.673 into 10 to the power minus 11. Newton gave this formula. Newton gave this formula. But the scientist who told us the value of G to be this was Henry Cavendish. Anyway, this is not a very important point, students. So students, this is called universal law of gravitation given by great scientist Isaac Newton. So as I told you, this is a famous story that he was once sitting under an apple tree and he wondered why apples fall down, and not only apples, he wondered why everything falls down. Why everything falls down. So when he was trying to find out the reason for this, he came up with this theory that is called universal law of gravitation. According to this theory, students, if we have two objects like this, then they will attract each other, and this attraction force is called gravitational force. And the value of this force, students, very importantly, and the value of this force is given by this very important formula, students. G m1 m2 by d square, students. So if we know the value of all these terms, we can find the value of force that is acting between these two objects, isn't it, students? Now students, let me give you some practical examples so that you can understand this law of gravitation even deeper. For example, suppose, students, there are two balls lying here like this. So as you can understand, students, as per this law of gravitation, these two balls basically will be attracting each other, isn't it, students? They will attract each other. They will apply force on each other. Do you agree with this, students? Yeah. See, if this law is true, then if two objects are there like this, they will attract each other, right, students? So students, there are two balls lying here like this. They will attract each other by applying force on each other, right, students? You understand? But students, you might be thinking that if these two balls are attracting each other, then they should actually move like this. They should actually move like this. A force is acting on this ball in this direction, so it should move like this. A force is acting on this ball in this direction, so it should move like this. Both should move towards each other and collide. But we don't find that happening in real life. We don't find that happening in real life, students. Why? Why, students? Why so? Why so? Look at this case, students. Once again, suppose we have these two objects, right? As per this law of gravitation, they will attract each other like this. They will apply force on each other. Then, students, they should actually move like this. But we don't see them moving like this. Why, students? Why, students? You understand my doubt? See, suppose this is a room, students. There are so many objects in a room. So this object must be attracting this object. This object must be attracting this object as per this law. This law says that if there are two objects, If there are two objects having mass, they will attract each other. So in this room there are so many objects, they have mass, so they all should attract each other, students. They all should attract each other, so they should start moving towards each other. But that does not happen, students. That does not happen. Why, students? Why? See, students, the thing is, I'll tell you that in our real life, these forces are definitely acting on these two balls. Forces are definitely acting like this on these two objects, and here also these forces are actually acting. There's no problem. Forces are acting, but students, the value of these forces is very, very small. The value of these forces is very, very small. So the value of these forces is so small that these objects do not move. The value of these forces is so small that these objects do not move. The value of all these forces is so small that these objects do not move. You understand, students? See, even if we take this example, suppose we have two people, students. They have mass. Say mass m1 of this lady, mass m2 of this lady. They are at some distance from each other. They will also attract each other, students, like this. The force is acting between them like this, students. But why don't they start moving towards each other? Why, students? The same reason. This force is very, very small. This force is very, very small. This force is very, very small. So there is no effect of this force as such. You understand? But students, there are places where this force will play an important role. So let us talk about, students, Earth. This is Mother Earth. And this is Moon, students. Now see, these are two objects. They will attract each other like this. As per this law, they will attract each other like this, students. They will apply force on each other. And here this force is large, students. Here this force is large. And so it has effect. Why it is large, students? See, the formula for force is G m1 m2 by d square, right? Now think, students. These objects like Earth and Moon, they have such huge mass. They have such huge mass, isn't it? They have such huge mass. They have very, very large mass, students. So the mass is very large. That's why the force is large and it has effect. It has effect. Same is the case with Earth and Sun, students. They both attract each other, and once again they have very large mass. So the force will be large, and that force has effect, students. But students, when we talk about our day-to-day life objects, then they have a small mass. They have a small mass, due to which the gravitational force is small. Gravitational force is small, and it does not have effect. Let me give you a example or a numerical which will make you understand this even better. So this is a question, students. So these are two balls, and the mass of these two balls is given as 1 kg, right, students? For normal objects, mass of 1 kg is normal. And these two objects are lying at a distance d from each other, that is 0.5 meter. Okay, students? Now as per this law of gravitation, these two balls will attract each other. They will apply force on each other. So the question is to find the value of gravitational force between the two balls. We have to find the value of this force, students. Okay, and value of G is given as this. So students, let us pay some attention to the value of G. I told you that value of G is actually 6.673 into 10 to the power minus 11. But here you can see that the value of G is given slightly different, 6.7. So students, see, this is the exact value of G, but if we use this exact value of G for calculation, then the calculation is going to be complicated. Isn't it, students? So many times in question it will be written that you have to take G like this, so that the calculation is simplified. Okay, students, anyways, let us find out this force. So the formula for this force is simply G m1 m2 by d square, students. So G is 6.7 into 10 to the power minus 11. M1 is 1 kg, M2 is also 1 kg, and D is 0.5, students, right? So this is 6.7 into 10 to the power minus 11, like this is half square. So this is 6.7 into 10 to the power minus 11 into 4, students. So this will come out to be this much, right, students? You can calculate this much of Newton. So the force acting between these two balls is this much, students. Now what do you think? Is it a large force or is it a small force? What do you think, students? Look at this, students. 10 to the power minus 11. Look at this, 10 to the power minus 11. You know, this is such a small force. You know, if I actually multiply these two, you know, I will have to write 0.1 2 3 4 5 6 7 8 9 and then 2 6 8. This much of Newton of force. So this is actually this much of force. You can understand how small this force is. Very, very small force, students. It's a very, very small force. So you understand, students, that gravitational force is acting on these two objects, but still we do not see them moving like this. Why? Because this force is so small. This force is so small that it has no effect. It has no effect, students. You understand? You understand the point? And why is this force so small, students? Because when you calculate this force, you have to keep this g here. And what is the value of g? That is 6.7 to 10 to the minus 11. So the value of g is very small, students. Value of g is very small. So because the value of this g is so small, that's why the force comes out to be so small. The force comes out to be so small that it has no effect in real life. Let us do one more question, students, which will, you know, clarify our concept even deeper, students. Now this is Earth and this is Moon, you know. So mass of Earth, ME means mass of Earth is given. You can see it is very large, students. 6 into 10 to the 24. This is a very large number, students. Mass of Earth is very big, obviously. Mass of Moon, that is also very large, 10 to the 22, students. Again a very large number. D, distance between Moon and Earth, that is also given, students. We have to find the gravitational force between Earth and Moon. You understand? So once again, students, we are going to use the same formula, G m1 m2 divided by d square. So students, let us put the value of g, that is 6.7 into 10 to the power 11 m1. So m1, mass of Earth, students. So that is 6 into 10 to the power 24. m2, that is mass of Moon, students. So that is 7.4 into 10 to the power 22. Divide by d, this distance, students, that is this much. So that is 3.84 into 10 to the power 5, students. No, there's a catch here, students. There's a catch here, right? See, this distance is given in kilometer. This is not SI unit, students. So we need to convert it in meter. So if you convert it in meter, it will be, you will multiply it by 1000. That is 10 to the power 3, students. So it will become 3.84 into 10 to the power 8, right? So that is what I need to write here, students. This is, let me make it 8, right? Now we need to calculate this. Now you can do the calculation, students. It will take some time. I write the result straightforward. That is 2.01 into 10 to the power 20 Newton. If you calculate, the force will be this much. And sorry, I did a mistake. We have to put a square here, students, right? D square. Okay. Now if you calculate, you will get this much, students. Now what do you think? Do you think it's a small force or it's a large force? It's very large force, students. Look at 10 to the power 20. This is a very large force. This is 2, 0, 1. Then you have to put 18 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This much Newton, students. So this is a very large force, students. Very, very large force. So now it will have effect. Now it will have effect, students. Now it will have effect. You understand? And why the force is very large? See, once again, the g here is small. There is no doubt about it. But look at the masses, students. Look at the masses. They are even bigger. They are even bigger. They are too big, students. The masses are too big. The masses here are too big. So g is small in this formula, but the masses here are too big. That's why the force is large, students. You understand? So that is what I'm trying to tell you, that in our day-to-day life, the mass of objects is small, and that's why this gravitational force is small, very small in fact, and has no effect. But when it comes to planets, stars, then the mass is very, very large, due to which the force is also large and it has good effect, students. You understand? So this is what I was trying to tell you in this slide. So in this case, in this case, in this case, in this case, you know, masses are not very large, due to which the gravitational force is small, you know, and it does not have much effect. We do not see these two people moving towards each other due to this force. But when it comes to planets, you know, sun, stars, mass is big and the force is also large, having significant effect. So students, this is a very important formula. This is called universal law of gravitation. As I told you before, universal law of gravitation. Now let us analyze this formula in greater detail, students. So we have two objects here of mass m1 and m2. The distance between them is d, and they attract each other by applying some force that is given by this formula. Now students, there are some important points here which you can notice. As per this formula, this force is proportional to m1 into m2. The force is proportional to m1 into m2. Right students? What does this mean? What does this mean? This means, students, that if m1 and m2 are more, if m1 and m2 are more, the force will also be more, students, right? If these two objects have more mass, then the attraction force between them will be more, students. That is what it means. And obviously it also means that if m1 and m2 are less, if the mass of the objects is less, the force between them will also be less, students, right? Now the second point here, students, the force is inversely proportional to d square. You can see force is inversely proportional to d square. Now what does this mean, students? See, what it means that if d is more, then the force is less, and if d is less, force is more. Inversely proportional means opposite will happen. If d is more, force is less. Now does it make sense to you? Yeah, definitely, students. Think about this. If we have two objects, close to each other, and in another case we have same two objects far from each other, students, far from each other. Now these two are going to attract each other. These two are also going to attract each other, right? Now what do you think? Use your common sense, students. In which case the force should be more? In which case the force should be more? See, students, in this case the objects are far from each other, so force should be less. So in this case the distance is more, they are far from each other, so force should be less, isn't it? In this case they are close to each other, so distance is less, right? But because they are close to each other, they should apply more force, students, right? So that is what we are telling here, students. You understand? Now the third point, students, let us talk about g, students. As I told you, g is a constant. Its value is 6.673 into 10 to the power minus 3 in SI unit. Sorry, 10 to the power minus 11 in SI unit. You must remember this, students, the value, right? And this is a constant, so its value, the value of g is always this. It will never change, students. See, students, we can find the unit of g. Unit. How can we find its unit, students? See, from this formula we can write that g is f into d square divided by m1 into m2, right, students? We can write g as f into d square divided by m1 into m2. Now from here we can definitely find the unit of g, right? For force I can write Newton, for d distance, so we'll get meter square. For mass we write kg, then again kg, because there are two masses here, so this is Newton meter square upon kg square. So this is the unit of g. This is a unit of g. This is also important question, important thing from exam point of view. You will be asked what is the unit of g. So this is a unit of g, students. So in fact, if somebody asks you to write the value of g, you should in fact write like this: 6.673 into 10 to the power minus 11 Newton meter square divided by kg square. That is what you should write if somebody asks you to write the value of g, the value along with the unit. Let us do this question, students, here. So in which of the cases gravitational force is more? So students, see what you have to do. This is part one of the question. So there are two situations here, this and this. You have to tell in which case gravitational force will be more, and similarly you have to solve 4 questions. Okay, so what do you think? In this case or in this case, in which case gravitational force is more? So students, we know that these two objects are going to attract each other like this. These two objects are also going to attract each other like this. In which case the force is going to be more. So students, we have just seen that force is actually proportional to m1 into m2. So you can clearly see that masses are more in this case. 5 kg, 5 kg. Here they are less. So masses are more in this case, students. So obviously in this case the force is more. In this case the gravitational force is more. Understood? Okay, now students, let us do this question, students. Once again you can see there are two objects, they will attract each other. Here also they will attract each other, distance between the objects is same here and here. In which case is the gravitational force more, students? So we know force is proportional to product of masses, So here the product of masses is 5 into 1, that is 5. Here the product of masses is 2 into 2, that is 4, students, right? So now what do you think? In which case is the force more? Here the product of masses is more, 5, here it is less. So obviously in this case the gravitational force is more, students, right? Let's do this question, students. In this case you can see there are two objects of mass 1 kg each. They will attract each other with some force. And these two objects will also attract each other. But here the distance is different. Masses are same, 1 kg, 1 kg, 1 kg, 1 kg. But the difference is distance in this case and this case. So we have seen, student, that force is inversely proportional to d square. So if d is more, F is less. If d is less, in this case you can see d is less, so it means force is more. So that is the answer. This case, d is less, force will be more, gravitational force will be more. Okay, friends, let us do this question. Once again, you see there are two objects, they will attract each other like this. Distance here and distance here is same, right? But see, here the product of masses m1 m2 is 1 into 4, that is 4. Here the product of masses m1 into m2 is 3 into 2, that is 6. So in this case the product of masses is more, so force will also be more. Students, you understand? So let us do this question, students. This might be a slightly complicated question, but I'm sure you will understand. So students, the question is like this. There are two objects, they are at a distance d from each other, okay, and as you can see they are attracting each other by applying a force of F0 value, right, students? They are applying this force of value F0 on each other, right, students? Now what we do, that we change the situation like this, students. We increase the distance between the objects to 2d, right? Now what do you think? Will they apply same force on each other? No, students, the force will be changed. You have to find the force, right, students? And then the second part of the question is that we further change the situation like this. We increase the distance further to 3d. Once again we have to find how much attraction force will act between them. If initially the force acting between them was F0. How to solve this, students? It's a very simple question. If you see students, in this case the force will be given by, the force acting, that is F0, will be given by g m1 m2 by d square, right, students? Right. So the force acting in this case F0 can be written by this formula, students, right? Now if we talk about this case, students, so the force acting in this case will be g m1 m2 divided by, on place of d we will write 2d, so 2d square, students, right? So this will come out to be g m1 m2, look carefully, divided by 4d square, right, students, right? Now students, please note that this thing, how much is this thing, students? G m1 m2 by d square, how much is this thing? That is F0, so we can write F0 on place of this, divide by 4, students, divide by 4, right? So on the place of this entire thing I have written F0. So students, the attraction force here is F0 by 4. The attraction force here is F0 by 4, students. F0 by 4. You understand? If the attraction force here is F0, the attraction force here is F0 by 4. So you see we have solved it easily. Now let us talk about this case, students. There will be attraction force in this case also. So we can write that force will be g m1 m2 divided by, on the place of d we'll write 3d. So this will come out to be g m1 m2 divided by 9d square, right, students? Now you see this thing is once again our F0. So we can write it as F0 divided by 9, So it means that if the attraction force here is F0, the attraction force here is F0 by 9. You understand? I hope you are getting the point, students, right? So students, this is an important thing. You can also keep this in mind. If the distance between objects is say d and the force acting between them is say F naught, gravitational force. Now if you change the distance to 2 times, then the force will decrease, 2 square times, basically 4 times. If you change the distance to 3 times, basically the force decreases by 3 square times, 9 times. If you change the distance to 4d, then the force will become 4 F naught divided by 4 square. If you change the distance to 5d, the force will become F naught divided by 5 square. Understand? So this is F naught by 4, this is F naught by 9, this is F naught by 16, this is F naught by 25. You understand? You can remember this, that if you are multiplying d by say 6, then the force will be divided by 6 square. That is what we are getting here. Okay students, if somebody asks you in your exam that state universal law of gravitation, so what will you write, students? This is a very popular question in exams, students. So you can write something like this. You'll get full marks, students. You can say that universal law of gravitation states that any two bodies having mass attract each other. That's true. That any two bodies having mass attract each other with force directly proportional to the product of their masses, as we have seen, with force directly proportional to the product of their masses and inversely proportional to the square of distance between them. We have also seen that. So it is saying that force is actually proportional to the product of masses and force is inversely proportional to the square of distance between them. That's true. The force acts along the line joining the centers of the object, right? And after writing this, you can also draw this diagram. You can draw two objects like this. You can show their mass m1 and m2. You can show that the distance between them is d like this, and then you can draw this force F and F. Right, and then you can write that this F is G m1 m2 divided by d square, right? So if you write this much, you'll get full marks, students. So students, what is the importance of this gravitational force that we are studying about? So students, this gravitational force is actually very important. Let me tell you few places where this gravitational force is very important. The first point, students, okay, focus here. It binds us to earth. It binds us to earth. See students, this is Mother Earth. This is Earth, right, students? So we all live on the surface of Earth like this. Do you know this? We are all living on the surface of Earth like this. When you walk on the surface. Okay. Now see, we are staying on the surface of Earth, but we don't fly away, right? We don't fly away in space. We don't fly away. We are bound to the surface of Earth. Why, students? Because of this gravitational force. Let me tell you how. See, let me consider this person, students. The person will have some mass, and this Earth also has mass. So this Earth is attracting this person. Like this by applying gravitational force, due to which this person is bound to Earth. Once again, if you talk about this person has mass and the Earth also has mass. So Earth is attracting this person. Like this by applying gravitational force. Right? You understand? So that's how we all are bound to the surface of Earth. Earth has mass. Our bodies also have mass. So there is a gravitational force acting between Earth and us. Earth is attracting us like this by applying gravitational force. And that's why we don't fly away. We are bound to Earth. You understand? I hope the point is clear to you, students. Okay. Now let me tell you the second importance of gravitational force. Moon revolves around Earth due to gravitational force. See, students, this is moon, and this is Earth. Right, students? We all know that moon goes around Earth like this. It goes around Earth like this. It is actually due to this gravitational force. We'll see how later in this chapter. Moon goes around Earth like this in a circular path due to gravitational force only, students. We'll see how. Same is the case with Our solar system, students, we have sun and then we have a lot of planets. You know the name of the planets like Saturn, Jupiter, Mercury, Venus, our Earth, you know. So there are many planets, students. All these planets are moving around sun. You know that. That is also due to gravitational force. We'll see how. We'll see how. Planets revolve around sun due to gravitational forces, friends. We'll see how, you know, this thing happens and this thing happens later on in this chapter. So don't worry. Tides, students. You must have seen tides in seas, in ocean, right? So tides in seas are caused due to gravitational force of moon on earth, right? See, this is moon, students, this is earth. So this moon has mass, this earth also has mass, right, students? So earth is applying gravitational force on moon like this. Moon is applying gravitational force on earth like this, right, students? They both will attract each other by gravitational force. You understand? This earth is applying gravitational force on moon like this. Moon is applying gravitational force on earth like this. You understand? So it is due to this gravitational force on earth due to moon that these tides are formed in oceans. So tides in oceans or seas are caused due to gravitational force of moon on earth. You understand? So these are some of the importances of gravitational forces, students. So students, now move to the next thing, that is called free fall. Now this is a very important part of the chapter and you will enjoy it. So let us see this heading. This tells attraction of earth on objects close to its surface. Attraction of earth on objects close to its surface. So students, let me tell you. So this is earth, mother earth, on which we live with students. Okay. So suppose there is an object here, you know. So this object will have some mass, say small m. And this earth will have some mass, say me. E stands for earth, students. Now so we have two objects here having mass. Now will these two objects apply force on each other? Definitely, students. There will be a gravitational force acting here. Earth will attract this force like this. Earth will attract this object like this, and this object will attract earth like this, students. You understand? So there will be force of attraction between the objects. There will be gravitational force between the objects. One object happens to be this small object of mass m, and another happens to be this huge earth, students. You understand? Now if this distance is given as d, then we can also write the value of this force, and the value of this force will be g m me divided by d square, isn't it? You understand? But now, students, think of another situation when this object is lying very close to the surface of earth. It is lying very close to the surface of earth, students, right? See, in our day-to-day life, there are a lot of objects, you know, which are close to the surface of earth, right? Say a stone is lying on ground. Say a stone is lying on ground. So that is close to the surface of earth, right? So students, we'll talk about this more, but right now you think that there is an object which is very close to the surface of earth like this. Now once again, earth and this object, they will apply force on each other, students. Earth will attract this object like this, and on earth also there will be a force like this, students. You understand? So there will be attraction force like this. Okay. Now this distance, students, between the object and the center of earth, this will be d. Now please understand, students, this d here, this d is very close to RE. RE means radius of earth. RE means radius of earth. Right, students? So the distance between the object and the center of earth is d, which is very close to the radius of earth. You understand? Because the object is near the surface of earth. Object is near the surface of earth. You understand? Now the value of this gravitational force, if we want to calculate, is G me into m divided by d square. But as I told you, we can write d as radius of earth, right students? Now students, many times this entire thing, G into mass of earth divided by radius of earth square, this whole thing is written at small g, and this m is mass of the small object, will be written as it is. So this can be written as m into g. So what is this g here students? G is capital G into mass of earth divided by radius of earth square. Let us calculate the value of this small g. I hope you understand what I am doing here. So see, value of capital G should be put here, that is 6.7 into 10 to the power minus 11. Mass of earth students, that is 6 into 10 to the power 24. Radius of earth, that is 6.2 into 10 to the power 6. Sorry, slight mistake here, that is not 6.2, that is 6.4. Right students? So see, mass of earth, that is a constant quantity. Mass of earth is not going to change. Right, so I've written the mass of earth here. Radius of earth, that is again a constant quantity. So I've written its value here. Now if you calculate all these students, you will get 9.8 meter per second square. So students, overall what we can say here is that if an object is lying close to the surface of earth, Earth attracts the object, by applying some force that is equals to m into g, where the value of g happens to be 9.8. You understand? Let me write this down students. Earth attracts an object close to surface of earth. Earth attracts an object close to surface of earth by applying gravitational force, equal to mg, such that g is equals to 9.8 meter per second square. You understand students? So let me give you some more examples so that you understand this very clearly. So students, this is ground. This blue line here represents ground students. Okay. So this is actually surface of earth. Ground is nothing but surface of earth. Now suppose, a boy is holding a ball of mass 2 kg like this. So is earth applying any force on it students? Yeah, definitely. Earth is attracting the object like this. Earth is applying a force like this on the object students. Right? Earth is applying a force on this object like this. And what is the value of this force students? That is m into g. So see, mass of the object is 2 and g is 9.8. So this will come out to be 19.6 Newton. So see, earth is attracting this object in downward direction towards itself by applying a gravitational force whose value will be mg. So we have put the value of m, that is 2, and the value of g is 9.8. So we get 19.6 Newton. So earth is applying a force of 19.6 Newton on this object in downward direction, students. And that's why if the person lifts the object, if the person removes his hand, what is going to happen? Due to this force, the ball will fall down. Students. You understand? Let us talk about this apple students. It is hanging from the tree. Its mass is 0.5. Is earth applying any force on it? Definitely students, earth is applying a force on it in downward direction. And the value of this force can be written as m into g. M is 0.5 and g is 9.8. So if we calculate, it will be 4.9 Newton. So students, earth is applying a downward force on this apple. Due to this, when this apple will be very ripe and it will separate from tree, then due to this force it falls down. Due to this force it falls down, students, right? Now suppose there's a car, students, that is lying on the ground like this. Its mass is 200. So once again earth is attracting it, towards its center. Earth is attracting it towards center. Center of the ground will be somewhere down. So earth is applying a gravitational force on this car like this. The value of this force is m into g. M is 200 in this case and g is 9.8, students. If we calculate, this force will be 1960 Newton. So earth is applying this much force on this car. Suppose a person is standing on ground, students. His mass is 50 kg. Once again earth is applying gravitational force on this. The value of this gravitational force is m into g. M is 50 and g is 9.8, students. You understand? That will come out to be 490 Newton. I hope you understand, students, what's going on here. Let's do this question. So you can see on the table there is a vase, flower vase. Suppose its mass is 2 kg, students. So obviously below there is ground. So this is an object close to the surface of earth. So earth is attracting it like this. Earth is applying an attraction force, a gravitational force like this. And the value of this force can be calculated by m into g. M is 2 and g will be 9.8. So this will come out to be 19.6 Newton, students. So earth is applying this much of force on the vase in downward direction. You understand? And that's why if there is no table, here, what happens? The vase falls down because of this force in downward direction. If there is no table, this vase falls down due to this gravitational force. So let's see one more situation, students. You can see this is ground, students. This tree here. Suppose some coconut is hanging like this, students. So suppose its mass is 1 by 4 kg. So earth will apply a gravitational force on this coconut in downward direction, students. That is why the coconut falls down. So what is the value of this force? M into g. So mass is 1 by 4 and g is 9.8. So you can calculate. That is the value of force, students. You understand? So the point which I'm trying to make here again and again through so many examples is that if an object is there, close to the surface of earth attracts the object in downward direction. And the value of that force can be found in a very simple manner by using this formula, students. Right?